It's time for another Algebra 2 Regents quick question walkthrough. And this one says, storybook researchers found that the population of field poppies in Oz was an initial population of 30, and that population grew continuously at the rate of 4% per month. The daisy population in Wonderland had an initial value of 40 and grew continuously at a rate of 3% per month. Find to the nearest tenth of a month how long it will take for these populations to be equal. The first thing I'd like to do is make my equations for each population. For the field poppies, I'm going to say f of t equals, and I'm going to be using my PERT formula because I see grew continuously. So I'm going to do p times e to the rt. My p for the field poppies is 30. E is just a number. R is my rate, which is 4%, or another way to say that is 0.04 in decimal form. So my full field poppy formula is 30 times e to the 0.04 t. For my daisies in Wonderland, my d of t says is growing continuously also. So again, I'm going to use my PERT formula. So I have d of t equals 40, because my p is 40. My rate is 3%, or 0.03. And so that's times e to the 0.03 t. The question is then asking me, how long is it going to take for these populations to be equal? I'm going to want to set both equations to each other, equal to each other. Essentially, I'm going to be doing f of t is equal to d of t, and I want to find that t variable to find out what time that is that they're equal to each other. So I have 30 times e to the 0.04 t equals 40 times e to the 0.03 t. First thing I'm going to do is I'm going to divide both sides by 30. That leaves me with e to the 0.04 t equals 4/3 e to the 0.03 t. Next, I'm going to divide both sides by e to the 0.03 t and e to the 0.03 t over here. The reason why I'm doing that is because then I can subtract the exponents. So I'm going to get 0.01 t over here equals 4/3. I still have a variable in my exponent though, so I'm going to need to take the ln of both sides equals ln of 4/3. The left side just becomes 0.01 t, and then that's equal to the ln of 4/3. To solve for t, I'm going to have 0.1 divided on each side. And solving into my calculator, I get t equals 28.768 ... which is approximately, I need it to the 10th of a month, 28.77 months is the length of time it's going to take for the populations to be equal. And I'm done with this problem.